Two things that we need to also be mindful of is anytime we have lines that are considered parallel and lines that are considered perpendicular. If the lines are parallel lines, two distinct non-vertical lines, are parallel if and only if their slopes are equal. Now, they say non-vertical lines because technically we can't compare the slopes of non-vertical lines. But two vertical lines, in fact, are parallel to each other. They just don't have a slope we can compare that to. And then we have if and only if. And in math terms, anytime you see if and only if, there's an abbreviation, IFF, IFFA, if and only if. That means it's not a misspelled word. If and only if in math terms is abbreviated by if with two F's. So if you ever see that, know that's what that means. But they're parallel if and only if their slopes are equal. For that matter, they are perpendicular. IFFA, their slopes are negative reciprocals of each other. Well, that's not very clear. What does it mean to be a negative reciprocal? That means you're going to flip the fraction and you're going to change the sign. Negative reciprocals means flip the fraction, change the sign. That is, let's start off with a slope, and let's say somebody give me a slope to go with. 3/4, that's a good one. I'll go with that. Thank you for that. Now 3/4 is the slope we're going to start off with. So that's the slope of the line. What would be the perpendicular? What would be the parallel first? So let's go ahead and list. What is the line, the slope of a line that's parallel to that? And what is the slope of a line that is perpendicular? And that's a long word. Parallel, as we mentioned, parallel is the same. So parallel would be 3/4. Now we also just learned that perpendicular slopes, you flip the fraction and then you change the sign. So this was positive and now it's going to become negative. So the perpendicular slope, clean things up, is negative 4/3. For that matter, let's try another one. Somebody else give me an example of a slope, just any slope. A negative one this time. All right, let's go with negative 2/5. Good idea. So now negative 2/5 is my starting slope. Parallel would be negative 2/5. And what about perpendicular? Well, I gotta flip this fraction over. Now keep something in mind here. When I flip the fraction over, I'm not taking any signs with it. And that is too close to the other one. Let me move that down. I am not taking the sign with it when I flip. The slope was negative. That's the sign. I'm flipping the fraction. So 2/5 becomes 5/2. Then I have to change the sign. Instead of negative, it's now going to become positive. So positive, my flipped fraction, 5/2. And clean that up, well, that's just 5/2. You really don't need the negative or positive at that point because it's understood. All right, so parallel slopes are equal. Perpendicular, the slopes are opposite reciprocals, or you flip and switch. Flip the fraction, change the sign from positive to negative, or vice versa. So if you want to try this problem here on your own, this will be a good time to pause. If you want to wait for the next one, or even the homework to try these out, then that's fine too. I'm going to go ahead and jump into it. It's asking me to find the parallel and perpendicular lines that have, with a slope-intercept form, passing through a given point, parallel and perpendicular to the line 2x minus 3y equals 5. Well, I have a point. I'm missing something here. I can't even begin to describe parallel and perpendicular unless I know something about the original line that I can compare to the new line. Now, parallel would have the same slope. Perpendicular, I have to flip and switch the slope. But all they gave me was a line of 2x minus 3y equals 5. They didn't give me a slope. So how do I find the slope of this line? You got a couple of options. You can solve for y and look at the number in front. There's also a shortcut for this one. And this is in the form ax plus by equals c, which is the standard form for a linear equation. Ax plus by equals c. Well, if I solve for y, I'm going to subtract ax. So I'm going to have negative ax plus c. And then I'm going to divide by the number in front of b, or the number in front of y, which is b. And we learned earlier that the number that goes in front of x is really the slope. Therefore, the slope from standard form is the opposite of a over b. That might be something worth committing to memory. It saves you from having to solve for y. If you don't like that, then you can always solve for y and find the slope in front of the number, but I promise you won't be any different than this. So now the slope here is really m equals the opposite of a, so opposite of positive 2 is a negative 2, opposite of a divided by b, and b is negative 3. But now a negative divided by a negative, that means my slope, my given slope is 2/3. So now I'm ready for part A. All I did right now is the background work to get me to this point where I can start A. It's parallel, so that means it's going to have the same slope of 2/3, and it's going to go through the point 2, -1. So my handy-dandy equation for the slope-intercept form, y minus y1 equals m, x minus x1, can help me with this. Y I don't change. y1 is the part of the point, so y minus -1 equals, and if you're comfortable enough, you don't have to write minus a negative, go ahead and just change it to a positive, as we know we're going to do next. 2/3, and then parentheses x minus the x value, which is 2. Now again, I see a fraction. If you remember from earlier, hey, I'm going to get smart ahead of time and save myself, the trouble. And I'm going to do this side first by saying 2/3 x minus 4/3, because now I have a bunch of fractions that I can save myself a headache, and instead of saying +1, I'm going to say +3/3. By doing that, now I'm making sure that all the fractions are playing nice. So I'm going to subtract 3/3 from both sides. So my final equation is going to look like y equals 2/3 x minus 4 minus 3 minus 7/3. That's just part A. Now, part B. But we've done the hard work behind it. Now all we got to do is make it perpendicular instead. So for part B, I'm going to move this down a little bit. For part B, let me change colors. Why not? For part B, I'm going to take my original slope, which was 2/3, but to make it perpendicular, I have to flip and switch. So 2/3 becomes -3/2. That's the only thing that's different. Plug in just the same. So I go to this y minus -1 equals -3/2, and then x, and then -2. Now you're probably thinking, oh, I got another fraction again. Work with this side of the equation first. Work with the right side of the equation, because you might not have a fraction when you're done. So let's try that. -3/2 x. Then -3 times a -2 is negative makes a positive, 6. And then this one doesn't have a fraction, this one does, over 2. And now 6/2, that cleans up. That's just 3. And you could have skipped that step too if you wanted. But it's really -3/2 x plus 3. And this one is just y plus 1. I don't have to change that to 2/2. Because when I go to solve this, I'm subtracting 1 from this. I don't want that fraction anyway. So here, I really have my final answer as y equals negative 3 over 2x, and then plus 2. I don't have a fraction, at least for the intercept portion of it, the part that I have to add numbers together, so there was no need to change for part B. Look for those things, it saves you a headache. Otherwise, you're just working with fractions later on. If they're supposed to be there, they'll show up. If they're supposed to be gone, they'll go. All right? So in summary for today's lesson, there are 6 different versions of equations of lines. Now, your textbook, for some reason, likes to put c on the same side and have it equal to 0. I generally don't necessarily care for that because c represents any constant value, positive or negative, so it really doesn't matter if it's on the other side. It just ends up being opposite of what it looks like when it's equal to 0. Because I moved it to the other side of the equation, it's opposite. Not a big deal. So if you see the ax plus by plus c version, just know it's the same as ax plus by equals c, which a lot of early algebra textbooks will teach. Vertical line is x equals some number. Horizontal is y equals a number. Vertical has no slope. But keep in mind that horizontal does not have no slope. In fact, it does have a slope. It just happens to be a 0 slope. Let's actually write the word 0. Don't want the 0 crossed out to be confused with empty or null or anything else you might have seen representing that. And it also looks like an O. And then we have the slope-intercept form. That's probably the most famous to everybody. That's what everybody knows. Y equals mx plus b. The point-slope form is the one that you should commit to memory. And then they have this 2-point form. I honestly think that this 2-point form is way too much work. I wouldn't bother with this one. Because if you have 2 points, what can you find from 2 points that we did earlier today? If you're given 2 points, find a slope first. Don't commit to memory some other equation that is confusing and you're probably never going to make use of. That's all it is. y2 minus y1 equals x2 minus x1 is the slope already. And they just move things around so you can compare the 2 points. That's really not necessary. You can use that. It is useful sometimes, but not often does it really come into play. I wouldn't bother with it. That is completely up to you, though. If you want a new one to commit to memory, you can definitely use that. All right? So that brings us to the end of this section. You do have a homework assignment that's assigned to you.